Welcome to the Deep Dive. Today we're unlocking the secrets of a security model that's really reshaping how we protect, well, everything digital. Zero Trust Architecture, or ZTA. You've likely heard the term thrown around, maybe quite a bit. But this deep dive, this is going to give you the ultimate shortcut to truly understanding what it means, why it's probably essential for your organization, and crucially, how to actually implement it. Our guide for this journey is a fantastic resource from NIST, that's the National Institute of Standards and Technology Special Publication 1835, Implementing a Zero Trust Architecture. You know, for the longest time, cybersecurity felt like building a castle. High walls, strong gate. Once you were inside, you were basically trusted.
The trusted internal network.
Exactly. But today, with data everywhere, remote teams, cloud this, cloud that, those walls, they just don't cut it anymore. That old perimeter idea has, well, it's pretty much dissolved, hasn't it?
It really has. It's a fundamental shift in reality.
So how do we rebuild trust in this totally fluid, always-on world? Okay, let's unpack this.
Yeah, that's the core challenge. And this NIST guide, it offers a genuinely pragmatic blueprint. It's not just theory, it's a roadmap born from some pretty extensive real-world testing. It explains how to move beyond that outdated perimeter thinking and implement a truly robust ZTA, one that protects your data, your resources, no matter where they are or who or what is trying to access them. What's really insightful here is understanding why this isn't just like another security product, but an essential philosophical shift for modern security.
Okay, so mission for this deep dive. We're going to distill the most important nuggets, the real game changers, from this NIST publication. We'll dig into why ZTA is needed now, how this very practical guide was built, quite an interesting collaboration there, the real-world challenges you might actually face implementing it. We'll look at the core components, the nuts and bolts that make ZTA work, and maybe most interestingly, the surprising, hard-earned lessons from putting it all into practice. And most importantly, we want to give you a clear, actionable roadmap for starting or maybe advancing your own ZTA journey. Right, let's kick off with that fundamental why. We know the perimeter's gone, sure. But what are the specific, urgent problems ZTA is solving that, traditional security models just can't handle anymore? Why is it catching on so fast, even becoming required in some places?
Well, the core motivation is pretty straightforward. Protecting enterprise data and resources is just incredibly challenging now, precisely because of that dissolved perimeter you mentioned. You've got hybrid workforces, data scattered everywhere on-prem, multiple clouds, the old model, trusting everything inside, fundamentally broken. So ZTA steps in. How? By focusing on preventing breaches and limiting lateral movement after a potential breach. It does this by continuously evaluating, verifying every single access request. Doesn't matter where it comes from.
Every single one.
Every one. It's a risk-based approach, really. And it starts from a position of assume compromise.
That assume compromise point feels key. So it's about not automatically trusting anyone or anything, even if it's already inside the network. That's a big mental shift.
It is, and it also applies to internal threats, which is a really powerful aspect.
What's the most common, maybe misconception you see organizations have about what that means in practice? Does it just mean grinding everything to a halt with checks?
That's a great question and a critical distinction.
Yeah.
The misconception is often that zero trust equals zero usability, or maybe that it's just about blocking external attackers. The real insight, though, is that a well-implemented ZTA allows for secure, authorized access for employees, contractors, partners, from anywhere, anytime, any device, and ideally without adding a ton of friction.
Okay, how?
It does this by explicitly verifying the context of each request. Not just who you are, but is your device healthy? Where are you connecting from? How sensitive is the resource? Are you acting weirdly? Access pattern anomalies. It ensures each access is safeguarded based on the real-time risk, rather than just a binary yes-no based on location.
And that helps with insider threats too, right? Before they can spread.
Precisely. It helps neutralize internal compromises or malicious insiders before they can really escalate. That's where so many modern breaches cause the real damage.
This shift, it sounds powerful, but maybe a bit daunting too. What makes this NIST guide so uniquely practical for navigating this? How do you come together in a way that actually helps organizations, on the ground?
Right. It wasn't just academic. It was this massive industry collaboration. The guide comes from the National Cybersecurity Center of Excellence, the NCKICOE, part of NIST. It's a public-private partnership. Industry, government, academia, all working together.
Right.
And this specific guide involved a consortium of, get this, 24 technology providers.
24. Wow. That's quite a crowd. Who are we talking about? Any big names?
Oh yeah, real mix. Fortune 50 leaders, smaller specialists, think heavyweights like AWS, Microsoft, Google Cloud, working alongside companies like Broadcom, Cisco, Okta, Palo Alto Networks, Zscaler, Appgate F5, IBM, Ivanti, Ping Identity, the list goes on. Together, they integrated commercially available technology stuff you can buy off the shelf to build 19 distinct ZTA example implementations.
19 different examples. Okay, what does that actually mean? If I'm an organization looking to adopt ZTA, what do these example implementations give me?
They're not just theoretical models on paper. They are practical modular solutions, built and tested in pretty realistic scenarios. They're documented in this NIST Special Publication 1800 series, and they map capabilities back to the NIST Cybersecurity framework, which many organizations already use. But it's really crucial to understand these are voluntary guides. They're examples, not regulations or mandatory practices.
So more like blueprints or case studies.
Exactly. The goal is to provide models that organizations can look at, learn from, maybe even emulate parts of. It saves immense time and resources by showing what actually works when you put these different vendor products together.
Okay, that sounds incredibly valuable, but implementing something this transformative, it can't be that easy, right? There must be hurdles. What were some of the big challenges they identified during this project? The things that you listening might actually run into?
Oh, definitely. Many organizations face hurdles, and they tend to fall into a few categories. First, just organizational buy-in and support. There's often this perception, right, that ZTA is only for giant companies, or it requires this massive investment, or maybe it'll just break things or annoy users.
So changing mindsets, managing expectations, it's not just about the tech.
Absolutely not. It's as much culture as it is code.
For organizations listening, what's maybe the single biggest blocker you've seen to getting that initial buy-in? Is it cost, complexity, fear?
Often, yeah, it's a mix of fear of the unknown and the perceived cost and complexity. Which leads to the second category, missing foundational pieces. You'd be surprised how many organizations lack really adequate asset inventory and management. They don't fully know all the applications, assets, data flows they need to protect.
Right. Hard to secure what you don't even know you have.
Exactly. And tied to that, often a lack of clear digital definition and tracking of user roles and permissions. Who should access what? That's critical for those fine-grained ZTA policies.
Okay. Organizational issues, foundational gaps. What about the tech itself? Putting it all together?
Yep, that's the third bucket. Technical challenges. Integrating all these different vendor products, which might be at different maturity levels, that could be tricky. Assessing the real capabilities, identifying the gaps between them, and there's often a lack of standardized ways to distribute and enforce security policies across all these different tools. You could end up with fragmented policies, different parts of the system not talking to each other, which raises that really important question. How do you even gauge your ZTA maturity? How do you pick the right approach when there's no single ZTA product and all your existing tools need to somehow play together nicely?
That's a critical point. So if there's no one-size-fits-all ZTA, how does this NIST guide actually give you a framework? How do you start building one? Let's talk architecture.
Right. The general ZTA reference design they used, it centers on three core components. You can kind of think of it like an airport security checkpoint. There's the policy engine, PE. That's like the lead security officer who looks at your documents, scans your ticket, maybe asks a question, and makes the access decision. Okay, you can go through.
Makes the call. Got it.
Then there's the policy administrator, PA. Think of that as the system that takes the decision from the PE and configures the gate. It tells the gate whether to open or stay closed.
Okay, manages the enforcement.
And finally, the policy enforcement point, PP. That's the actual physical gate, or the turnstile, or the firewall rule, the thing that actually enables or denies your access based on the PA's instruction.
PE decides, PA configures, PAP enforces.
Exactly. And these three are supported by various policy information points, PIPs. These are all the data sources feeding intelligence into the policy engine. Your identity system, endpoint security data, network logs, threat intelligence feeds, security analytics, all that context we talked about.
That analogy really helps clarify PE, PA, PPP, PIPs. Okay, so that's the conceptual framework. How did the NCCOE actually put this into practice across those 19 different implementations? You mentioned phases.
Yeah, they used a phased approach, kind of a crawl, run, evolve strategy, you could say, starting simpler and building up complexity. So the EIG crawl phase, EIG, stands for Enhanced Identity Governance. This phase focused on ZTA without heavy cloud capabilities initially. It often used existing identity and access management solutions to sort of double up as policy engines. The focus was on protecting on-premises resources, using basic security analytics. They deliberately showed how ZTA principles could work even with more legacy-type solutions.
So proving it wasn't just for brand new cloud-native setups.
Precisely. Then came the EIG run phase. This built on the crawl phase, but added cloud capabilities. Now, policy engines weren't limited to just ICAM products. They started incorporating things like device discovery, device health checks, and setting up secure tunnels to cloud resources.
Getting more sophisticated.
Right. And finally, the SDP, microsegmentation, and CC phase. This one lifted basically all the constraints. They implemented more complex, mature ZTA approaches, things like software-defined perimeter, SDP.
Which is like making your resources invisible unless you're explicitly allowed to see them.
Exactly. It cloaks the resources. Then microsegmentation, which carves the network into tiny isolated zones, limiting lateral movement drastically, and Secure Access Service Edge, SATE, which is a broader cloud-delivered model combining networking and security services.
And they didn't just theorize about this. I understand they really went to town testing these concepts. How did they simulate a real environment?
Oh yeah, they built these 19 solutions in this pretty sprawling lab setup. You had multiple simulated enterprises, a branch office, even a coffee shop Wi-Fi scenario, and a WAN service provider emulation. This near real-world setup let them really kick the tires on these concepts under various conditions. And that generated some really critical insights, some hard-earned lessons.
Okay, building 19 different ZTAs in a lab like that must have thrown up some fascinating insights, maybe some unexpected challenges or gotcha moments. What were the key takeaways that you listening should really pay attention to?
Absolutely. First, the guide really emphasizes those fundamental capabilities. Continuous authentication, re-authentication, not just of users, but also the requesting endpoints and the resource hosting endpoints, plus authorization, of course, and highly desirable, continuous verification of endpoint health. So not just, is this laptop okay now, but is it still okay? Is it behaving normally?
That continuous part seems absolutely vital for actual zero trust. What did they learn in that initial crawl phase, dealing with maybe older tech?
Well, in the EIG crawl phase, the key finding was that many commercial ICANN solutions, the identity systems, they didn't really integrate smoothly out of the box with network-level PEPs, those enforcement points, or with endpoint protection tools. Not well enough to act as full ZTA policy engines on their own.
The integration challenge.
Yeah. And also, those initial builds struggled with fully supporting resource management, authenticating and verifying the health of the server or the application endpoint itself on an ongoing basis. It's like you check the user's ID thoroughly, but you don't really check if the building they're trying to enter is structurally sound or hasn't been compromised.
That sounds like a pretty significant gap. If your identity system isn't talking properly to the network gates or the endpoint agents, you lose that whole continuous verification loop. What about the run phase, when cloud came in?
Precisely. In the EIG run phase, they demonstrated more capabilities, secure tunnels to cloud, monitoring cloud traffic, better device checks, but challenges persisted. For instance, some builds lacked a really robust endpoint protection platform, EPP, that could integrate directly and automatically remediate issues. So you might detect a problem, but fixing it was manual.
Okay. Lack of automation.
Right. And also, a lack of consistent ways to determine a confidence level or a trust score was noted across different solutions. Getting one unified risk score for any given access attempt proved tricky.
Which brings us back to that integration point. How do you ensure seamless integration across all these different vendors in a complex ZTA, especially given these findings?
That's exactly what the SDP, microsegmentation, and ZTNA really hammered home. Deeper integration between products from different vendors is absolutely crucial for effective ZTAs. It's maybe the biggest technical challenge. They found that having multiple policy engines in a ZTA, which is common, you might have one for network access, one for apps, they often don't share information effectively.
Siloed intelligence. Exactly. Leading to this fragmented understanding of risk. Like, one PE might know an endpoint is non-compliant, but another PE, looking at user behavior analytics, might not have that critical piece of context. Ideally, your SUM security information and event management, and your OSO for security orchestration, automation, and response platforms. They should be feeding real-time threat and event info directly into the policy engine. So decisions are based on the absolute latest picture. Data security tools, risk information from vulnerability scanners, user behavior analytics, all need to integrate tightly with that PE. And while some of those SDP solutions can manage resources to an extent, the finding was that dedicated resource management tools, properly integrated with the PEs, are generally better for their specific capabilities and depth.
This has been incredibly insightful, really getting into the weeds of the practical challenges and solutions. Okay, so for you listening right now, if you're thinking about starting your ZTA journey, or maybe you're already on it and want to improve, what are the actionable steps, the key takeaways from all this real-world NCKey experience? Right, the guide boils it down to 7 crucial steps. And maybe I can add a little insight from the findings to each. 1, discover and inventory the existing environment. Sounds basic, right? But the real insight here is that most organizations vastly underestimate the complexity. You need to go way beyond just listing servers. You need to map dependencies, data flows, applications, services on-prem, cloud, everywhere.
Know thyself, basically. But really know thyself.
Exactly. Use discovery tools, monitor traffic, understand current access patterns before you try to change them. 2, formulate access policy to support the mission and business use cases. Okay, once you know your assets, the trick isn't just who gets access, but under what conditions and crucially why from a business perspective. Always apply least privilege, deny by default, and base policies on data criticality, not just a user's job title. 3, identify existing security capabilities and technology. Before you run out and buy new shiny ZTA tools, really dig into what you already own. Firewalls, ICAM, endpoint security, SIEMs. What can be leveraged? What can be repurposed?
Don't rip and replace if you don't have to.
Right. The best new components will integrate with what you have, not force a total overhaul. 4, eliminate gaps in zero trust policy and processes by applying a risk-based approach. This is where you actually design the protection. The insight here is segmentation, isolate critical resources, and enforce access controls at multiple layers, the application, the host, and the network. Think many small smart gates, not one big dumb one. 5, implement ZTA components and incrementally leverage deployed security solutions. Start with the basics. Make sure your SIEM, vulnerability scanning, patching are working well, then build incrementally. Foundational ZTA pieces. Strong identity, ISAM. Strong multi-factor authentication, MFA, and endpoint protection that assesses device health continuously. Add other components based on your specific risks and needs, always prioritizing that integration piece.
Crawl, walk, run again.
Exactly. 6, verify the implementation to support zero trust outcomes. You cannot just set this up and assume it's working. Continuously monitor traffic. Use your tools to audit and validate that the access decisions being made are actually the right ones. And periodically test. Run through common use cases, attack scenarios, make sure it holds up. And 7, maybe the most important, continuously improve and evolve. ZTA is absolutely not a one-time project. It's a process. The threat landscape changes daily, technology evolves, your business needs change, your ZTA has to adapt, upgrade components, integrate new defenses, update policies. It's a constant journey.
A journey, not a destination. Got it. Wow, what an incredible deep dive. It's crystal clear that zero trust architecture is way more than just a buzzword. It's a strategic, ongoing journey that really fundamentally transforms how organizations have to think about cybersecurity. And this NIST guide, built on all that practical experience from so many collaborators, it genuinely gives you an actionable roadmap to start that journey with some confidence.
It really does. It emphasizes that ZTA limits threats by doing that continual verification, by applying behavioral analysis, dynamically assessing risk in real time. It's about protecting each resource individually, everywhere, creating these tiny, intelligent perimeters around absolutely everything.
So what does this all mean for you listening? Hopefully it means you now have a much clearer understanding of why your organization should be considering ZTA or maybe continuing to evolve it, and the practical steps, the potential pitfalls to make it happen. That idea that knowledge is most valuable when it's understood and applied really rings true here, doesn't it? And here's a final provocative thought for you to mull over. If ZTA fundamentally shifts trust away from the network perimeter and onto individual resources and identities, how might this change the very definition of what an enterprise network even is in the coming years? Will the concept of a distinct network even matter in the same way? Or will it just become this abstract fabric connecting dynamically secured endpoints and resources? Something to think about until our next deep dive.